Okay, hi everyone. Nice to meet you today here on our webinar. So we'll have a topic today about applying AI to software engineering processes. So today's webinar will be more like a high-level overview of this topic and introduction to the subject. We'll talk about a bit about the theory of AI, about the software engineering processes, which require some additional attention for those possible issues that we face with them. Then also we'll talk about the community, AIFORSE community, and those activities which we do to manage this topic and to support development of AI tools and their application to software engineering processes. And also we'll review some examples of real tools which already exist. Some of them are in prototype mode yet, but some of them are already in production. But that's a good demonstration of how AI can already help us with software development. So a few words about myself. Again, my name is Valentin. I'm working as a software engineer with mid-size and enterprise size solutions, with primarily in roles as business analyst and solution architect. So being as a founder of the AIFORSE community, I'm trying to find ways how to make software engineering processes more exciting and smarter, both for engineers side and for the customer side. We'll talk about the difference a bit later. A few words about the community and the safe harbor. So we are a community. We don't really produce or create any software or products. We don't provide really software services in any form. We don't create any tools. So we are just about the methodology and the best practices, cases, and approaches, how AI can be used for managing software engineering processes and artifacts. We don't depend or belong to any vendor. We are independent in this sense. Usually people ask, how do we make money? We are charging corporate members for admission fees, but still our community is free of charge for individuals, and we propose still a lot of information for free, just contributing to the community. Our vision is that we foresee that sometime later, with the development of technologies, of methodologies for delivering software, with still some time we'll get to the situation when the delivery of the solutions for particular problems will be quite immediate. So we are trying to approach to that time as fast as possible with the help of AI. Few words about the AIFORSE community. So you might already heard about that we are creating a collaboration platform to exchange all the information about applying AI to software development. So our main target audience for whom we prepare all our materials and collect and consolidate the information, they are like three parts. Software engineering companies, whether they develop some products, meaning software products, whether they do some system integration work and deliver some solutions, as well as outsourcing companies. The second part is companies who develop tools, independent whether those tools are AI driven or non-AI driven, but still these tools are used for software engineering and by software engineering companies. Those tools are like ticket trackers, IDEs, build tools, wikis, and so on and so forth. And the last part is companies which use custom software solutions. Basically, these are customers who buy big enterprise solutions, which is critical for their business or operations. So what are the main problems in software development now? There are a lot of different reviews and surveys. What are the main fails and what are the main issues why the software cannot be just delivered in a good way, in a reasonable time and reasonable budget. So main problems are like, I can list few of them, but you can think up about few more problems which we'll discuss with you in the end of the webinar. So the first issue is that companies, basically there are just two main reasons which I wanted to share with you. That first is 40% of projects, software development projects, they are delivered out of time, and 29 of them, they not of them, but at all, are delivered out of budget. This means that we either have a good quality of a software, we either have a good quality of requirements, we don't match the real business needs which we are trying to solve with the software. We struggle with some development issues, the quality of code is low, we don't really cover the end-to-end scenarios, we have issues with integration, the code base is growing, the cost of each next change is growing, and the complete process turns into the complete mess. So that is the problems which we aim to solve, and let's see how we are planning to do this and how we are doing that. What are the main solutions which are known nowadays? So first of all, the most popular, if you ask any engineer, it will be agile ideology, agile methodologies, agile practices. So the real boom of this this way to solve like software engineering processes, it was like about 6, 8, 9 years ago, and it does solve some of the issues, but we already know that if you are, for example, working on a big project, you cannot really apply agile in a clean way, because you need to manage all the documentation, you have complex solutions which needs to be integrated, and so on and so forth. So agile solves just a part of problems which we have. Another potential solution is DevOps. DevOps practices, they hit their boom about like 3-4 years ago, and it's still ongoing. Again, DevOps addresses only part of the issues, like related to deployment, to automated builds, to infrastructure management, but there are still a lot of unresolved problems which we have. So we just thought up that AI, as is currently in its pretty well-known and good phase of its development, is again on the road, so we might use it. So why are we looking at the AI? Let's consider some of the examples. So first of all, this is a classical example which I usually show. A picture which is shown for just 1/10 of the second, like 10 milliseconds, and you need to calculate the number of people on this picture. So doing this for just 1/10 of the second, or even for just 1 second, with what I'm showing you, is quite a challenging for a person, meaning that the person has some limitations of his ability to perceive data in quantity and in quality per particular time frame. So if you'll have enough time to do that, to count all those people, you can find that there are like about 14 people on this screen. Some of them are visible good, some of them are not really visible. But AI can solve this issue, can solve this problem much more faster than we can. It can do even faster than for 1/10 of the second. It can do like for 1/25 of the second as a frame, as a video frame. So the question is, does AI solve this problem really good or not? So you can see this on the picture. You will be looking at the kites. So some AI implementation can locate all the 7 kites, like 100% match. But as for the people, you can see that only 1, 2, 3, 4, 7 people are found. But I calculated there shall be about 14. So that's just 50%. So 50% is, as you understand, not quite good level of accuracy. But what this shall mean? This shall mean that some of the tasks are solved perfectly by AI, some of them not. So it means that we shall conclude from that we shall take a look what AI can solve excellent for us, better than we can do that, and try to use that for the problems which we have. Few words about the AI trend and why it's so popular nowadays. So actually AI is not something really new. It's about like 50 to 70 years old. And about, I would say, 70–80% of approaches, of formulas, of methodologies, they are well known, and they were well known even before. So in the end of the day, AI is just a mathematics and statistics. So nothing really new we have in this field. And the phenomena of the popularity of AI and machine learning nowadays is that we have a rapid growth of our calculation power of our machines. So if you had some machine learning task or mathematical task which could took you, for example, 2 weeks 40 years ago to process those data, process those equations, so now it will take you just maybe I don't know, 20 minutes to process this with a chip installed in the cell phone. So that's quite impressive, and basically that's the main reason why we have this boom, this boom nowadays. Few words about the AI, about the forecast, how AIs and the AI-driven solutions can benefit in revenues during the next like 7 years. So this is a forecast by Tractica, and this is for entire market, for the solutions which can be applied to any problems in any industry, not particularly aimed to the one we are aimed to, like software engineering, but at all the trend, I believe, will be the same across the industries, whether AI is applied to like forecasting of sales, or in marketing, or in healthcare, or in our area. Still, AI is, as I already said, is not a silver bullet. So you can see that's another example. There was a model trained to identify puppies and muffins, and that accuracy of that model was not so high. It couldn't really distinguish. You can see again, it's 50-50. Sure, we can do that. We can distinguish them quite good, but AI cannot always do that. So again, we need just to find those areas where AI can do that very good and try to utilize those sections, those parts. Few words about the abilities of the AI. So according to the DARPA, there are 4 parts, like perceiving, learning, abstracting, and reasoning. you can think about the same abilities of a person or of a child who is growing and learning, right? So perceiving is the first, and they are kind of ordered in the way they are developed, the best developed nowadays. So perceiving by AI is the best developed nowadays. So there are a lot of libraries, open libraries like OpenCV by Google, where you can take it and just apply to your video which you just shot it, or with your cell phone, for example. You can upload it or from the dash camera, for example, and you can try to learn the machine to identify like signs or people. Actually, it's already learned. You can just apply it and add some additional value on top of it. Also, another example of perceiving is voice recognition. So everybody uses like Siri or Cortana or other voice voice-driven assistants, like also Google Voice. So that's developed nowadays pretty well. The second level is learning. So it's still good, not so good as perceiving, but with new approaches of deep learning and reinforcement learning. So machines which are trained once will not like be anymore using the same amount of data and knowledge which they know. They can learn with the new data coming up, and they can learn with the help of a user. And a good example is that how reinforcement learning is now trained is that you can apply that for games. And while a person is playing, so system continuously analyzes what actions, which moves, which keystrokes lead to successful results in games, and it can just repeat the same actions without even understanding what that means. But with the time later, it can even play better than people who teach that system how to play that. The next level is abstracting and reasoning, basically. So for abstracting and reasoning, AI is not really good with that nowadays. I can provide a few examples what is abstraction is. So you can ask like any person, or even a child, what is common between, for example, apple and I don't know, and a plum, for example. He and this person can tell you that's a fruit, right? But to learn a system to do that in automated way, not just write rules, right? Not just write some hard code those dependencies. It's quite challenging nowadays. And reasoning is another part which AI is not good at as of now. This is basically like logical consequences of some events. So if A is B, then and B is C, then A is also C, right? This is a very simple example, but there are some in logic. In the study of logic, there is such a special term which is called syllogism. So it basically defines such logical conclusions, and AI is not really good at that, as I already said nowadays. So how AI can actually be applied to the software? There are two coins, right? Two sides. We call that user or customer facing side and engineering facing side. So on the left side, you can see that we have some application. It can be, for example, Uber, which we use, and it can actually utilize AI to calculate a cost of your ride, to calculate an optimal route of your ride, to find your driver as fast as possible. But this example, this part, this side of applying AI to software is not what we are really working on. We are working on the other side. So there are engineers which create those Uber apps and Uber like servers and business logic. and they use some tools, right? They create tasks, for example, in Jira. They manage their design documentation with some wikis well known. They write their code, they write their tests, they use some build tools. So that's the apps which they use in day to day in their work. So that's the side, that's the tools which we aim to apply AI to write code better, to manage requirements better, to fix issues better, even finding those issues, those defects automatically with the AI. So we are on the right side here. When we use AI for software engineering, meaning for software engineering processes and for managing software engineering artifacts. Few words about how AI can be used. So this is some statistics, not for AI, but what are the most popular approaches and methodologies nowadays in software engineering world, how to make software better, ordered by the popularity, right, by the applicability. Unit testing, let's take a look at the first three, like unit testing, coding standards, and continuous integration. We can ask ourselves, why are they like top three options? My personal view and thinking and understanding is that they're quite easy to follow and to implement them. You don't need really any infrastructure. You can do this automated, um, like as we already discussed, like continuous integration is basically an example of a DevOps. Coding standards, there are a lot of static code analyzers which can, before you commit it to your code to the branch, it can just tell you what's wrong with it, right? But those rules which it checks, they are hard coded, and we'll talk about that also. Unit testing is also very straightforward approach. So I just have a feeling that the simpler approach or a solution is, the simpler it will be apply AI to it. So that's just a feeling, and later on in this slide deck, yeah, I'll show you some examples of the tools which already use AI to solve these problems. So let's move on. And also one more important notice is that there is a statement, you know, right, that the computer was invented to solve problems which didn't exist before a computer was invented. So what does it mean? So when we have something really game-changing coming to the world, it might change everything. So we even shall not think about how we can apply AI to have problems nowadays. Maybe, possibly, again, that's just my feeling or guess, maybe AI, which is, as many of people and engineers say, that's something which really changed the world, changed the games, the game rules, right? Maybe we just think about what will be the processes of any processes, like in general, right, and particularly in our area, software engineering processes, when AI will come in place, right? So that's a separate topic, just to think about this in the background, but that's still like the common AI brings the paradigm shift, I think. We are getting now to the AIFORSE products. Again, those are not like software engineering products, as I already mentioned, not some particular tools. We just call it products, like because it should have some name, right? So 5 main products which we currently offer to our members, both corporate paid and individual free. We have AIFORSE Framework, AIFORSE Compliance, Landscape, Networking, and Conference. I would like to pay more details and tell more about the framework and the landscape. So the framework, yeah, let's start from the landscape. So the landscape is a kind of an analytical overview of the market, of the current state of the industry of applying AI to software engineering tools, to software engineering processes, and to manage software engineering artifacts. So this landscape is created. So yeah, you can see there are two axes, right? So on the top, you can see that we have different, let's call them phases of software engineering. They are not always mandatory, depending on what you are developing, depending on the size of your team, depending on the product and methodology which you use. But we just needed to somehow aggregate, to somehow group the tools. So that's why we just took those phases. Not necessarily that you have all of them, right? So we have project management, requirements, design, code construction, quality management, and maintenance. And you can see an interesting statistics that the most popular part is of application of AI. So yeah, in the table you can see figures. They represent the tools which we succeed to found on the market globally. And so the most popular, as you can see, is code construction. So you can ask yourself, why is it so, right? That's there is a reason, sure, because there is a GitHub which has really tons of lines of code, and you can easily load all those gigabytes or terabytes of code locally to your machine. You can think up of some machine learning algorithm, or you can build some more AI-driven model, and you can start learning those or teaching like those models with this information. So you have really a good baseline for that, because as I already mentioned, as AI is basically about the mathematics and statistics, you need to have that statistics, right? You need to have the data, and GitHub perfectly provide that data for you. But the issue is with other areas like the requirements of design, quality management. So do you really know any examples where you can take the data for free, you can load them and use? So me, for example, I don't know that. Yeah, sure, there are special training sets for each of that of those area like parts, right, groups, but they are just few. You cannot really test all your hypotheses with that, and that's why we don't really have a lot of tools for other areas. Another axis which we introduced, which we realized we need to introduce, is that the maturity level of that tool, which is present in the diagram, right, in the landscape in general. So we have, let's go top to bottom. So we have B2B ready. These are tools which are already tested enough and have enough level of maturity that you can just take it and apply in your processes, in your work, right? You can see we have them quite few, right? They are just 14. Again, this entire statistics entire report was built globally, right? So around the world, you can just think about that. Around the world, there are just 14 tools which apply AI to manage your software. So having, I don't know, 100 million software engineers, having software engineering industry since the previous year is the top industry, given the most like revenue among other industries, being a horizontal industry, it just has 14 AI-driven tools to manage software engineering. That's quite strange because AI is perfectly applied in a lot of other areas. As I already mentioned, in managing sales, in healthcare, in fintech. And AI is basically what is coming from the software engineers, right? So there is a reasonable question why software engineers don't use it for themselves. There might be different reasons, but the main reason is that all those areas which I mentioned where AI is successfully applied nowadays, they are like vertical markets, where everybody understands where like money comes from and what we can spend on and how we can get those money back from the additional profits, right? But the software engineering is completely another story. It's a horizontal market which works and plays following its rules, and well, I think that's the main reason why it is so. So we have also B2C ready internal development and landing page. So a few words about the internal development. Sure, if it's internal, it's not publicly available information about those tools, right? So we just put here what we succeeded to find. And the last row is landing page. You can see the majority of tools, they are just saying that they're pretending to have something being developed, but in fact they're just like landing pages with not clear information if there is something really valuable behind that those pages, if there is a working model, if there are satisfied customers, if there is a proven return on investment. So in general, there are still some interesting tools which we can look at, but as you already might mention, we have this topic for the next webinar, which will be in 2 weeks, where we will dive deep into this landscape and we'll review some of the tools, the most interesting tools which are presented in it. The second part which I wanted to mention also is AIFORSE framework. So again, this is not a software engineering framework, not not a library. This is just a suite of standards, a methodology, a best practices combined together, which can help you to start using AI for your software engineering process. So you remember what I just mentioned 5 minutes ago, that we have a lot of data, right, for training models on code, but we don't really have data to train models on requirements, design, or test, whatever, test cases, test suits, whatever that is. That's why we just realized that the first thing we shall do before actually going to the era of AI for software engineering, we need to pass some pre-era, we need to make some preparation to that step, very important step. So we are currently at the phase which we call AI enablement, where we want to somehow describe and standardize what you should do to start using AI tomorrow, let's say, or in a half of a year or in a few years, right? So we described the main principles, and we are now describing the main processes related both to software engineering and applying AI to it, to them, right? So it will be our next after the next webinar. So it will be in 4 weeks, where we in details will review the main principles. Sure, not the entire framework, but the main principles which basically drive it. Yeah. So now I'm done with the theory, and we are getting to the most interesting part, where I want just to show you some of the. I'll show you just 3 examples, right? 3 demos. So they are not pretending to be working demos. They are just like demos taken from the sites of those vendors. Again, we are not paid for the advertising of those demos, and some of them, they are really, you will not even know what the name is, as far as I remember. That's just for the educational purposes, so to show you that there is already something being developed. So the first one, sure, will be going like following the standard process. Like first, we are interested in how to design software, right? We'll take a look how to work with the UI design, with the wireframes, right, and the mockups. The next will be working with the source code, and this last will be testing. So let's take a look at this. It has no sound, so it's just a video. I'll be commenting this. Yeah, so here is a UIZART tool. This is a startup which is aiming to recognize the hand-drawn mockups, right, and then convert them to something. It can be converted to a sketch. It can be converted to a source code, to HTML and CSS, for example. I'm not sure if they're planning to have some support for some like classical standard frameworks, front-end frameworks. But yeah, you can see an example. So here in this demo, we have a sketch file generated, so you can open it and see what we got from that hand drawn sketch. So here it is, pretty simple and straightforward, right? Good. The next one, yeah, and sure, you can work with sketches, you usually do that. So the next one is AI for coding, for managing source code, for writing source code. Yeah, this is a British London startup which is called DivBlue. So you can see what they propose. Again, as far as I know nowadays, they don't really have any working commercial ready or industry ready solution, but that they would pretend to solve, right? So they can see what are the tests, which unit tests basically, right? Unit tests which you have for your code, and calculate the coverage. And if they like see that coverage is not enough, they can automatically generate more unit tests to have 100% source code test coverage. Another good example is that when you are creating some software, right, you need to have a login form. So login form is something which has been already created like million of times by different developers, and it's from the first point of view, it's quite easy, right? But how well, or how are you sure really that it doesn't have some security flaws, and someone cannot just delete your account base, like remove it from the database, right? Information of your customers. And the last one is AI for testing. Yeah, again, just one example. Yeah, I just wanted to give a brief introduction. So I already told you in the very beginning, and I showed you that AI can perfectly work with visual recognition, right? So there are already free open libraries for that. And we saw that it's applied at the design phase when you can recognize the mockups. So the same approach, basically, when you have already those mockups implemented in the code, you can test them, right? So that's an example how visual recognition can help us test UI. So when you have different versions deployed, right? So you want to check what was changed. So do this manually. It basically not will, but usually it requires a lot of time, right? And if it's done by a person, sure, a person can get tired with that, right? He might have a bad mood that day. He might just, let me show that again while I'm commenting on this. Yeah, he might have like bad mood on that day. He might just accidentally skip some issue. So what does this tool do? So it just basically visually compares interfaces and highlights differences, and automatically creates a bug report, discrepancy bug report for you, and then you can just go through that and analyze if that's really a defect or not, and you can mark that it's a defect, and if it's a defect, so the similar discrepancies in the future, identified later for another versions, will be also classified as errors. But if something you identified personally as not a defect, then something similar, kind of a defect spotted later, will not be also reported to you again. Another good example, or a separate topic, right? An ethical, ethics part of the AI. So there are a lot of arguments, like, right, for AI and against AI, and the main argument they are about that AI will destroy workplaces and will leave us without the work, and without the money will do all the work without us. So for the favor of the AI, I can tell a few things. That first, there is such a trend currently in the world, which I just see, that AI is not proposed or treated as something which substitutes people, like a particular person, right? But something which augments them, right? Which helps you to solve your tasks. That's the point of view which I like. And there are another forecasts that AI, sure, it will destroy some jobs, but it will also bring new, right? Especially if we as software engineers, they will be needed someone who will create those models, who will train, maintain them, and check that they're doing what they are intended to do, right? And another good example, so this is a picture of a famous painter, of a famous artist, French artist Renoir. I like to tell a story about him, right? That before he started, this is, yeah, as I said, this is the most famous, the most expensive, his work. So before he started working on pictures and creating like chef d'oeuvres like this, he was like painting just a plate, very simple and straightforward and understood work. And one day he got fired. He got fired because of a simple reason, because at work, and basically he liked that work, right? Because he can do those paintings day and night. He was like well paid for that. But one day he just was fired because of automation came to this industry. Machines like became doing this work instead of him, right? That, sure, that was when he was young, and he created this work much more later, but that was a change in his life brought by machines, and this like led to very impressive results, I would say. So finishing our webinar for today, if you are not registered yet, I propose you to do this, or you can do this right now or after the webinar. So I'll repeat, it's completely free for all the individual users, and being registered, you can find a lot of useful information. So you can find AI-driven tools, which I just mentioned today, but you can find that landscape, it's available on the website, and you can be notified when we'll provide updated versions of that landscape. You can get access to the framework. So now you can get, you need to write to us to get that, but sometime later, by the webinar, which will happen in the 4 weeks, we are planning to make it like publicly available, some part of it, sure, not the entire one. So as you're doing this today, you can continue doing that, attending webinars, future webinars and meetups, local meetups, which we'll have. We are trying and spending a lot of efforts to find and collect really relevant information from the internet, news and content, like how AI is, particularly in our area, right, in our subject matter, how AI is used. So we are providing some references to articles, some good videos, So that's another reason to join. Sure, you can find people and talk to them. So people who create those tools. If you are curious or interested about how that or this works, so it will be much more easier for you to reach out to those people, being a part of the community. And sure, if you have some ideas, if you feel that there are some activities, some routine work that you are doing day to day, or your colleagues struggling with that kind of activities, and you feel that you have a solution for that, and you are just interested in how to move further with that, how to implement that, that's what you can find also with the community, to get support, to get suggestions for further development of your ideas. Another announcement, that we are looking for local chapter leaders, for local ambassadors who would like to represent the community locally, basically to drive the local meetups with all the support which we can provide, support of tools, materials, and methodology of doing that. So if you are interested in that, please write us. And the last thing is basically our motto, something that drives us. We just want to create better software better, and we want to spread our ideas how this can be achieved, and share those ideas with the other engineers and people, and like everybody who is working in the engineering field. The last slide comes with the other references to resources where you can reach out to us, or where you can just join us or follow us. We have, sure, beside the standard like Facebook, link, Twitter, we also have an account with some set of articles in Medium. Also in GitLab, that's where we store our framework. As I said, it's not publicly available yet, but it will be available soon. On the YouTube, we have some videos from the conferences where we were talking about the AIFORSE, but the most valuable thing there is a collection of other like conferences, or just videos, or meetups, or just examples of tools, everything which is related to AI for SE. So if you join the channel, you can find all those pretty well grouped into the playlists. We have also a Telegram channel if you want to quickly ask some questions or discuss something with the community, so you also can join and write your questions right there. So we got to the end of today's webinar. So thanks for your attention. I believe I shedded some light on this topic. I brought something new for you, and yeah, and provided some meal for thoughts and for further activities. So yeah, please join us, follow updates, and sure, we will share this recording later during the next day, and there you'll find also an invitation to the next webinar, which will be dedicated to the AIFORSE landscape and the tools which are represented in it. So thank you one more time for your attention. Have a great time. Bye.